Hello everyone, welcome to my YouTube class. In this video we are going to talk about the binary search technique. Search means finding an element in an array. Now if the element is found, we are going to return the index of that element, else we will return -1. Why -1? Because -1 cannot be the index, that means the element is not found. And this is based on the divide and conquer. Now what do I mean by divide and conquer? Given an array, you divide into two equal parts. Now why two equal parts? Because it is binary. Binary means two equal parts. You will search on the left subarray or you will search on the right subarray. But the prerequisite for this binary search is array has to be sorted, and if the array is not sorted, we cannot apply the binary search. Next, this binary search is faster than the linear search. It is faster than the linear search that we have already discussed. Let's take an example of this array. Now what is the prerequisite? The prerequisite is the array has to be sorted. Now if you want to apply binary search, the array has to be sorted, else you cannot apply. Now let's take the array as 10, 20, 30, 40 and 50, where the array is sorted. Now what we do, we first want to know what is the key element that you want to find. Right, because I said search. What you want to search? You want to search some key element, and let me take the key element to be equal to 20. Let me take the key element to be equal to 20. Now first what we do, we divide the array into two equal parts. Now if I want to divide the array into two equal parts, I need to know what is the midpoint. And how do you find the midpoint? Yes, say me, how do you find the midpoint of this array? It is the lower index, which is 0, plus the higher index, which is 4, whole divided by 2, and you get the midpoint as 2. And you get the midpoint of as 2. Now what we do, we search, we compare the key with the mid value. Is 20 equal to 30? No sir. If 20 was equal to 30, the element was found. The next comparison is 20 greater than 30? No, 20 is not greater than 30. 20 is less than 30. Now say me, if 20 is less than 30, shall I search on the RHS subarray or LHS subarray? You will search only on the LHS subarray. Why? Because the array is sorted. Now, since 20 is less than 30, on RHS of 30, you will find all the elements greater than 30. You will find all the elements greater than 30. That means if 20 has to be present, it cannot be present on the RHS subarray. Why? It is very obvious, because 20 is less than 30 and on RHS of 30 you have all the elements greater than 30. Therefore, what we do, we discard this array. And what the next step, it says we will search in the remaining part of the array. And again what we do, we find the midpoint. Now what is the midpoint of this array? The lower limit is 0, the upper limit is 1, whole divided by 2. 0 plus 1 by 2 is 0, 1 by 2 is integer by integer is integer. That means this becomes the midpoint. Now again you search, is 20 equal to 10? No. Is 20 greater than 10? Yes, 20 is greater than 10. That means if 20 has to be present in an array, it should be present on the RHS of 10. It cannot be present on the LHS of 10. Again we discard this array. Now only one element is remaining. Again we find the midpoint. How do we find the midpoint? Lower limit is 1, upper limit is also 1, whole divided by 2, and you get mid equal to 1. Now again compare, is 20 equal to 20? Yes sir, 20 is equal to 20. That means element is found, key is successful. At what index we are finding? Because it should return the index. At what index we are finding? 1. And what is the value of mid? 1. That means the element is found at the mid index. Now always remember, the array is between the lower limit and the upper limit. Now let's take another example and try to understand this. How do we solve it? 10, 20, 30, 40 and 50. I'll say 0, 1, 2, 3 and 4, and let me take key is equal to 60. Now what is the first what we do? We search 60 in the complete array because I don't know where it is. Hence, what is the lower limit to start with? It is 0. And what is the upper limit to start with? It is 4 or n minus 1, which is 4. Now, the first step of the procedure is find the midpoint. Now, what is midpoint? Lower limit plus the upper limit whole divided by 2, and you replace 0 plus 4 by 2 is 2. Hence, the midpoint will become 2. Now, you come to this midpoint and you compare. Is 60 is equal to 30? No. 60 less than 30? No. 60 is greater than 30. That means since the array is sorted, if 60 has to be present, it can be present only on the RHS subarray. It cannot be present on the LHS subarray. Hence, what we do? We discard this array. We discard this array. Now say me, what is the value of lower limit now? Yes, say me, what is the value of lower limit now? The value of lower limit is 3. The value of upper limit is 4. The value of upper limit is 4. Again, we find the midpoint. Now, what is midpoint? 3 plus 4 divided by 2. Lower limit plus upper limit whole divided by 2, and 3 plus 4 is 7 by 2 is integer by integer is integer, and you get 3 as the midpoint for this array. Again, you compare. Is 60 equal to 40? No. Is 60 less than 40? No. 60 is greater than 40. That means if 60 has to be present, it has to be present on the RHS of 40. It cannot be present on the LHS of 40. Therefore, we discard the LHS subarray along with mid. Now, this is the only subarray left now. What is the lower limit? It is 4. And what is the upper limit? It is also 4. It is also 4. Now find the midpoint. What is midpoint? Lower limit plus the upper limit whole divided by 2 is equal to 4. 4 plus 4 is 8. 8 by 2 is 4. Now this is the midpoint. Now again you compare. Is 60 equal to 50? No. Is 60 less than 50? No. 60 is greater than 50. Now that means it has to be present on the RHS subarray. Hence I need to discard this as well. Now I have discarded the complete array and we did not find 60. Hence we return -1 as answer. Now you can see over here the value of lower limit and upper limit are being changing based on the value of key. I want you to think how do you change the value of lower limit and upper limit based on the value of key is equal mid, greater than mid or less than mid. Please pause the video here, make the appropriate notes and think how do we change the value of lower limit and the upper limit. Now I am going to explain that as well. Thank you. Let us see the relationship between the lower limit, the upper limit and the key element along with mid. Now, suppose this is the array. We know that to apply binary search, the array has to be sorted. Let the array be 10, 20, 30, 40, 50 and we want to search 30 is present in this array or not. Now, initially we will search in the complete array. Now, if I want to search in the complete array, what will be the lower limit? It will be 0. And what will be the higher limit or upper limit? It will be 4. Is that okay? Now, I write here lower limit is 0 to begin with. Upper limit is 4 or okay, it is 4. I'm sorry. Upper limit is 4 to begin with. You find the midpoint. How do you find the midpoint? Lower limit plus upper limit divided by 2 and the midpoint will be 2. This is where the midpoint is. Now you compare. What are you doing? You are comparing. Is 30 is equal A of mid. What I am doing over here? I am comparing if the value of key is equal A of mid. Now what is the value of mid? The value of mid is 2. And what is A of 2? A of 2 is 30. Is 30 equal to 30? Yes sir. It should give you answer as 2 because the element is found at index 2. Hence, what shall I return? Can anyone say? What shall I return? Can anyone say? You shall return mid. You shall return mid. Is that okay? Key is 30. A of 2 is 30. 30 equal 30 is true. That means you say return to key is found at index 2. I hope till this everyone is very clear about it. Now let me take key is equal to 20. Let's take key is equal to 20 and try to work on the procedure again. Now you find the midpoint again. Lower limit is 0, upper limit is 4. Midpoint is lower limit plus upper limit whole divided by 2. How do we find the midpoint? If you want, let me write here. Midpoint is equal lower limit plus upper limit whole divided by 2. Now lower limit is 0, upper limit is 4, 0 plus 4 is 4, 4 by 2 is 2, therefore the midpoint will become 2. Now what is the value of key? 20. And what is A of 2? 30. Is 20 equal to 30? No. 20 is less than 30. Therefore, let me compare the next thing and I say else if the value of key is less than A of mid. Now what is the value of key? The value of key is 20, A of mid is 30. Is 20 less than 30? Yes sir, 20 is less than 30. Therefore, we will continue our search on the LHS subarray. We will continue our search on the LHS subarray and we are not going to compute on the RHS subarray along with mid. That means I need to discard it. I need to discard it. Now if I discard it, say me, what will be lower limit? Lower limit is 0. Did it change? It did not change. But the value of upper limit, which was 4, now should become 1. Now should become 1. Now see over here, this was the array 30 and here mid was pointing. Now that means the upper limit will become mid minus 1. That means the upper limit will become mid minus 1. Are you getting it? Because you are searching on the LHS of mid. Again I am saying, since you are searching on the LHS of mid, what will be the upper limit will become? Upper limit will become mid minus 1 and the lower limit remains intact. And you are seeing that the lower limit is remaining intact. Now, if I say upper limit is mid minus 1, 2 minus 1 is 1, the upper limit will become 1. Upper limit will become 1. Now, again what we are doing? Again we are dividing the array into 2 equal parts. That means, again I have to repeat it and whatever is repeated should be in the body of loop. And you can use any loop here. As of now, I just write loop. Let us see which loop I want to write it. Shall I write for loop, while loop, do while loop, whatever it is. I say loop. Now again you say mid is equal to lower limit plus upper limit divided by 2. 0 plus 1 is 1. 1 by 2 is 0. Midpoint will become 0. Now what is key? Now this is midpoint here. This is midpoint. What is key? Key is 20. Is 20 is equal 10? No sir, 20 is not equal to 10. Is 20 is less than 10? 20 is not less than 10. That means I need to search on the on the RHS subarray. Now if I want to search on the RHS subarray, say me what will happen? This is the RHS subarray. Say me what will happen? That means the value of lower limit. Now this was the value of mid. This was the value of mid and this was the value of L. Now the value of L should become mid plus 1 because you have to search on the RHS of mid. Because you have to search on the RHS of mid. Else I say lower limit is equal mid plus 1. Else I say lower limit is equal mid plus 1. Now what is the value of mid? 0. 0 plus 1 is 1. That means lower limit is pointing over here. Now still we have one element to be searched. Therefore again I say loop. That means lower and upper are equal. Still I will run the loop. Still I will run the loop. Is that okay? Now mid is equal to lower limit plus upper limit divided by 2. 1 plus 1 by 2 is 1. Now what is the value of key? 20. And what is the value of A of mid? A of 1. That is also 20. Is 20 equal to 20? Yes. Return mid. It will return 1 to the point from wherever it is called, saying that the search is successful. Let me run this on another set of input. Then we will see what should be the terminating condition and how shall I return minus 1 and how shall I return minus 1. Let's take another array and I write here 10, 20, 30, 40, 50. This is the array 0, 1, 2, 3, 4. What is the lower limit to start with? 0. Upper limit to start with is 4. And let me take key is equal to 40. Let me take key is equal to 40. Now mid is equal to lower limit plus upper limit divided by 2. This is 2. This is the midpoint. This is lower limit. This is upper limit. Now check. What is the value of key? 40. Is 40 is equal 30? No. Is 40 less than 30? No. That means 40 is greater than 30. Therefore, you come to the else part. That means you need to search on the RHS of mid. Now, this is the RHS of mid. Hence, this should become the lower limit, and that is what you are saying. Lower limit is equal mid plus 1. Now, what is mid plus 1? 2 plus 1 is 3. Now, still the array is there. Remember, always the array is between the lower limit and the upper limit. Go back, because I said look, mid is equal to low plus high by 2. 3 plus 4 is 7. 7 by 2 is 3. Integer by integer is integer. Key. Now, what is the value of key? 40. A of mid, it is also 40. Is 40 equal to 40? Yes, sir. You will return mid. Now, the value of mid is 3. That means the value of key is found successfully. The value of key is found successfully. Now, let us take one unsuccessful thing and we will see how does the array behave. Now, let's take 10, 20, 30, 40. Let this be the array. And I want to search 50 in this array which is not present, or let me say 25. I want to search 25 in this array which is not present. Now, what is the value of lower limit? It is 0. What is the value of upper limit? It is 3. In this case it is 3. Now, we find the midpoint. 0 plus 3 is 3. 3 by 2 is 1. This becomes the midpoint. Okay, now search. Key is 25. Is 25 equal to 20? No. Is 25 less than 20? No. That means if 25 is present in this array, it should be present on the RHS subarray. Are you getting it? Hence, we say lower limit is equal mid plus 1. What is mid plus 1? It becomes 2. And this is the search thing, and this array is discarded. Now, this is the lower limit. This is the upper limit. This is where we want to search. Still, are there elements in the array? Yes. And always remember, array is between lower limit and upper limit. Go back. Mid is equal low plus high by 2. 2 plus 3 is 5 and 5 by 2 is 2. And again, this becomes the midpoint. Now, what is key? 25. Is 25 equal to 30? No. Is 25 less than 30? Yes, 25 is less than 30. That means if 30 is present, if 25 is present, it should be present on the LHS of 30. It should be present on LHS of 30. Therefore, you say u is equal to mid minus 1. Now, what is the value of mid? 2. 2 minus 1 is 1. Hence, upper limit will become this. Now, already I said the array is between lower limit and upper limit. The array is not between upper limit and lower limit. That means, is there any element from lower limit to upper limit? No element between lower limit to upper limit. Hence, this becomes the termination condition. And what shall I write over here? I say while lower limit is less than or equal to upper limit. Now, what is the value of lower limit? 2. What is the value of upper limit? 1. 2 less than or equal to 1 is false. You come out, that means the element is not found. And if the element is not found, what shall I return? I shall return minus 1. And what should be the initial value of L? Yes, can anyone say me? The initial value of lower limit should be 0. And what should be the initial value of upper limit? It should be n minus 1. Because the last element will be the upper limit. If the number of elements are 4, the upper limit will be 4 minus 1, which is 3. And you have to declare one more variable. What is the one more variable we will declare? We will declare mid, and we will see how do we make this as a function itself and write the program. I hope you understood it. If it is less, you will search on the LHS subarray. If it is greater, you will search on the RHS subarray. If you are searching on LHS subarray, the upper limit will change. If you are searching on the RHS subarray, the lower limit is changed. And if it is equal, you will return the midpoint. You will return the midpoint. Is that okay? And when do we stop it? Whenever the value of lower limit becomes greater than upper limit. See here, 2 greater than 1 is false. You know that there is no element called as 25. Hence, you come out of the loop and you return minus 1. Had the element being found, you would have returned mid from then and there. No statement after the execution of return will be executed. We know that this is how the functions work. I hope that you have understood this. Please pause the video and make the appropriate notes. Then we will see how do we write the program for the same. Thank you. Let us see how do we write the program for the binary search. Before you see this video, again pause the video and try to write the program yourself. We say hash include stdio.h and write the prototypes, whatever is necessary there. I will directly start with the int main. What is the input for this question? The input for this question is an array. Therefore, let's take int a of, and I can say int a of 100 or int a of 1000. Now what happens whenever you declare an array? An array will be created. Let's take it as 0, 1, 2, 3, 4, so on up to 99. This is array A, and you can store maximum of 100 elements, but we can store n elements as well. Therefore, I say here int n, and you read the value of n. How do you read the value of n? You say scanf %d ampersand n. Now assume that the value of n is 5. You want to store the starting 5 numbers. And how do we read the array? Please remember that in order to apply binary search, the array has to be sorted, else binary search cannot be applied. Therefore, whenever you enter the array elements, be sure that the array elements are entered in the ascending order or the sorted order. Now let us assume that the array is 10, 20, 30, 40, 50. Now, what is the question? Binary search. Now, in this array, I want to search. What I want to search? It is the key element. Therefore, we need to read the key as well. I write here printf enter key to be searched. I say here enter key to be searched. I write enter key to be searched. Now, how do we read the value of key? We say scanf %d ampersand key, and I need to declare a variable called as key. Assume that the value of key is 40. What does the function will return? The function will return mid. Mid means what? Where, at which index it is found. Which index it is found. Is it okay? Therefore, let us write one function called as bsearch. You can give any function name. Bsearch means binary search. In which array we want to search? In this array A I want to search. How many array elements are there? There are n array elements, which is 5. And what I want to search? I want to search key. Now assume that the value of key is 40. That means I need to implement the binary search function. Let's say bsearch. What is the first parameter? Integer one-dimensional array. Therefore, I write integer one-dimensional array. What is the second parameter? The second parameter is n. And what is the last parameter? The last parameter is key. Therefore, I say int key. Is that okay? Now, see here. The value of lower limit is 0. The value of upper limit is n minus 1. Now what is n minus 1? N minus 1 means 5 minus 1. 5 minus 1 is 4. Therefore, this is the lower limit. This is the upper limit. Now 0 less than or equal to 4. Yes, mid is equal to 0 plus 4 by 2. It is 2. Now you compare. What is the value of key that I have taken? 40. Is 40 equal to 30? No sir, 40 is not equal to 30. Is 40 less than 30? No. Else will be executed. Lower limit is equal mid minus 1 and 2 plus 1 is 3. This is where the lower limit will be. Now the lower limit is 3, upper limit is 4. Go back. 3 less than or equal to 4. Yes, mid is equal to 3 plus 4 is 7. 7 by 2 is 3. Hence the value of mid will now point to 3. Now compare. What is the value of key? 40. And what is a of 3? It is 40. 40 equal 40 is true. Return mid. Now what is the value of mid? 3. 3 is integer. Therefore, the return type of the function has to be an integer. Now this 3 will be stored, has to be stored over here, and let me store it in some variable called as m and declare that variable m. Now what is the value of m? The value of m is 3. The value of m is 3. See here, 3 means it is found. It has found. Okay. Now let's take another example and let me try to find 50 in this array, 50 in this array. Now this is lower limit, this is upper limit, this is midpoint. Needless to say, 0 less than or equal to 4. Yes, midpoint is already done. Now 50 is equal to 30, no. 50 less than 30, no. Else lower limit is equal mid plus 1. Now this is the lower limit. Go back, lower limit is 3, upper limit is 4. 3 less than or equal to 4, yes. 3 plus 4 is 7, 7 divided by 2 is 3. This is where the midpoint will be found. Now check, is 50 equal to 40? No. 50 less than 40, that is also no. Therefore we say else lower limit is equal mid plus 1. Now this becomes the lower limit. This is the only element that I have to find out. Now I am finding 60 in this array, 60, okay. Now go back, 4 less than or equal to 4, yes. Mid is equal to 4 plus 4 by 2. And what is 4 plus 4 by 2? It is 4 only. Now is 60 is equal to 50? No. 60 less than 50? No. Else lower limit is equal mid plus 1. Now the lower value is 4, mid is 4, upper is 4, 4 plus 1 is 5, lower limit will become 5. Go back. Lower limit is 5, upper limit is 4, 5 less than or equal to 4 is false. You come out and you return minus 1. Now minus 1 means what? The element is not found. Therefore, what is the next thing that I need to write in the main? Can anyone say? What is the next thing that I need to write in main? Yeah. If the value of m is equal minus 1, you say printf key not found. It is key not found. Okay, else means what? It will be 3. 3 equal minus 1. No, it means the value of key is found. It means the value of key is found and we stop the procedure. Write the prototype for read array, void read array int star comma int, and binary search, b search, int, b search, int, integer one dimensional array, integer n, integer key, and this becomes the code for the binary search. Very important question. I hope that you have understood it. Thank you friends for watching my video. You may pause the video over here and make the notes of the program of the binary search. Thank you.